Large aquarium contains only two kinds of fish, guppies and swordtails. 3/4 of the number of guppies is equal to 2/3 of the number of swordtails. Then what fraction of the fish in the aquarium are guppies? So I'm going to use G as guppies and S as swordtails. And just to translate the first part of that second sentence into math, 3/4 G equals 2/3 S. All right. Now, one thing that would be very easy and very helpful would just be to have the ratio of guppies to swordtails. If we just had that, we'd be in good shape. So I'm going to divide both sides by S. So I have 3/4 G over S. Now that G over S, that is the ratio that I need. So I need to solve for that. I'm going to solve for that by multiplying by the reciprocal of 3/4. So I'm going to multiply both sides by 4/3. And I'm going to get G over S equals 2 times 4, 8 over 3 times 3, 9. The ratio of G to S is 8 over 9. And so another way to say that is that for some n, G equals 8n and S equals 9n. That means the total number of fish is 17n. And so the fraction of guppies would be 8 over 17. And 8 over 17, in fact, is the answer. In a certain parking lot at 10 a.m., the ratio of trucks to cars was 1:3. Between 10 and 11, no vehicle left, and for some integer n greater than 0, some positive integer, n more cars and n more trucks entered the lot and parked there. And so we want the new ratio of trucks to cars. How does that compare to 1/3? Well, there would be very intuitive ways to do this problem, and if you understand quick intuitive ways to solve it, that's wonderful. I'm actually going to show the more tried and true algebraic method here. So I'm going to just say for the ratio of trucks to cars is 1:3. So I'm just going to say that trucks equals some number k, cars equals 3 times that number, 3k. All right, so we're going to need a little bit of room to do this calculation. So the ratio of trucks to cars, well, that would be k plus n over 3k plus n. How does that compare to 1/3? And so what I'm going to do is I'm going to pretend that there is an imaginary symbol between these two columns. It may be an equal sign, it may be a greater than or a less than sign. It's going to be one of the signs, one of the relations, greater than or less than or equal. And what I'm going to do is I'm only going to do moves that would not change an inequality. And so that way, even as I follow my steps, I'll be preserving whatever relationship is there. And so, fortunately, both k and n are both positive numbers, so I can multiply and divide by positive numbers. That's fine. I can add and subtract. All of those keep the same order of the inequality. So what I'm going to do here is simply cross multiply. So I'm going to get 3 times k plus n on this side, and I'm going to get just 3k plus n on this side. This becomes 3k plus 3n. This stays as 3k plus n. Subtract 3k from both sides, and I just get 3n compared to n. Well, n is a positive number, and so 3n has to be bigger than n. And so column A has to be bigger. And that's our answer. Column A is bigger. Answer choice A. This is a tricky problem involving two cars. So they start out traveling from A to B. Car X is initially behind Y, but it's going faster. In fact, we're told that car X's speed is 1.5 times car Y. So in other words, the rate of X equals 1.5 times the rate of Y. All right, that's an important equation. We'll need that later. So let's think about this scenario a little more. We'll visualize what happens. At 1:30 p.m., car X and Y are at the same place, and they are some unknown distance from B. We don't know how far they are from B at 1:30, but we know they're at the same place because car X is passing car Y. Later on at 3:15, car X, because it's going faster, gets to B, and car Y is 35 miles away from B. So one way to think about this is in terms of the gap. The gap between them is 0 at 130. The gap between them is 35 miles. And so we can actually set up a D equals RT for the gap. So we know the distance, 35 miles. So it increased from 0 to 35 miles in that time. What is the time from 1:30 to 3:15? Well, that is 1 hour and 45 minutes. It's most advantageous to write that as an improper fraction of an hour. And so that is a full hour plus a quarter of an hour. So that is 7/4 of an hour. So that is the time. So we'll set up a D equals RT for the gap, and we want to actually find the R. So the D we know is 35 miles. The time we know is 7/4 of an hour. We're going to write that divided by 7/4. We're going to write that as a fraction, the reciprocal, 4/7. We'll cancel the factor of 7. 35 divided by 7 is 5. And then we get 5 times 4 is 20. So the gap speed is 20 miles per hour. In other words, the gap between the cars, once car X is in front of car Y, the gap between them is getting bigger at 20 miles per hour. And so another way to say that is car X is going 20 miles an hour faster than car Y. So let's just say X is the speed of car X, Y is the speed of car Y. So we already have that equation, X equals 1.25Y from the paragraph itself, from the prompt paragraph. It told us that. And then we just found out from this gap speed that X minus Y equals 20. In other words, car X is going 20 miles an hour faster than Y. Well, now we have two equations for two unknowns. What I'm going to do is just simply substitute this equation into this equation here. And so we replace the X with 1.25Y minus Y. Well, 1.25 minus 1Y will leave us with 0.25Y. 0.25, of course, is a quarter. So multiply both sides by 4, and we get Y equals 80. So the speed of car Y is 80 miles an hour. Well, car X is going faster than car Y, so car X is going 100 miles an hour. These are two very fast cars. We don't know where this is. They probably both will get speeding tickets. But car X is going 100 miles an hour. That is, in fact, the answer. So we go back to the answers, and we select 100 miles an hour, answer choice E.
Okay, the question tells us that the taxi charges 25 cents for every additional half mile. This means the taxi must charge 50 cents for every additional mile. Now in the question, we're comparing the trip's distance with column B, 16 miles. So let's calculate the total cost for a 16-mile trip. To do this, we'll begin with our 85 cents charged for the first half mile, and then we'll pay 50 cents for every mile traveled after that, which will be 15.5 miles. When we calculate this, we get a total cost of $8.60. Now the question tells us that the total cost was $8.85. So this trip must have been longer than 16 miles, which means column A is greater than column B, which means our answer is A. In order to maximize the number of watermelons in the shipment, we need to minimize the weight of each watermelon. So we'll say that each watermelon weighs exactly 15 pounds. Now let's try one of the answers in our answer choices. A convenient number here is 60. If there were 60 watermelons, then the weight of our shipment would be 900 pounds. Notice that this is only 1 pound too many. As such, we cannot have 60 watermelons, so we must have 59. So our answer is C.
What is the sum of all the multiples of 5 that are greater than 100 and less than 200? So in order to do this, we have a formula. This formula is that the sum of an evenly spaced set of numbers is the number of terms times the average of the first and last term. And so we need to figure out these three numbers. We need to figure out the lowest term, the highest term, and the number of terms, and then we could use this formula. So first of all, let's think about this carefully. Obviously, we know that 100 is 5 times 20. Well, that's not included. But the first number that would be included is 5 more than that. So 105, well, if we add 5, we have one more factor of 5. That has to be 5 times 21. That's included. And that is a sub 1. That's the first term. At the other end, we know that 200 is 5 times 40. That's not included. But if we subtract one factor of 5, we will have one factor fewer. That would be 195, which has to be 5 times 39. And that is the last term. So now we know the first and the last term. Well, that's helpful. Now, how many terms are there from that first term to the last term? Well, from 5 times 21 to 5 times 39 is the same number as from 21 to 39. And here we have to use inclusive counting, so it's going to be 39 minus 21 plus 1 for inclusive counting, which is 18 plus 1, which is 19. So now we have all the pieces. We have the number of terms, we have the first term and the last term. So let's put these together. When we put these together, plug these in, we get 19 times 105 plus 195, everything divided by 2. Well, 105 plus 195, that happens to equal 300, a nice round number. And so what I'm going to do is a bit odd. I'm going to split that up into 3 times 100, and I'm actually going to multiply the 19 times 3. 19 times 3 is 57. Now I'm going to take the divided by 2, and instead of dividing the 100, which is a nice round number, I'm going to divide 57 by 2. Well, we know 56 divided by 2 is 28. 58 divided by 2 is 29. So 57 divided by 2 is right between them, 28.5. And 28.5 times 100 is 2,850. So that is the sum of the list. We go back to the answers and we choose answer choice D.